Okay, so we're starting complex fractions. So this first step isn't going to really make sense until we get to like number 2, but more so number 3 and 4. So it says make it one nice happy fraction on top and one nice happy fraction on bottom, meaning you want your denominator to be combined, like you want it to be combined. Okay, and like I said, this will make more sense in a second. Write one, divide the other, flip the second, multiply, order, GCF, factor, cancel, and simplify as much as possible. So what I want you to realize, y'all, is what does a fraction represent? Division. That's all this is. So yes, this looks like a nasty fraction on top of a nasty fraction, but really, y'all, so this is one fraction over one fraction, so I can rewrite it, and I get x plus 2 over x squared minus 4 divided by x over x minus 2. Did I change anything, or did I just write it different? I just wrote it differently. Does it look more achievable now? To me it does. I think this looks terrible. Like, this scares me. Okay? But this does not scare me. Okay? So remember, when you have division, you flip the second and multiply. So we're going to flip this and end up multiplying. But I'm going to factor what I can first. Can x plus 2 factor? Or GCF or anything? No. So I'm just going to rewrite it as x plus 2. What about x squared minus 4? It's a difference of squares. So it's going to be, so we get x minus 2, x plus 2. Now we're changing it to multiply, and we're flipping. Well, x minus 2 doesn't simplify, or sorry, not simplify, but factor, and x doesn't either. So once I have it factored and set up, I can start canceling. So what can cancel? The x minus 2's, what else? X plus 2's. Now, I have nothing left on top, but what do I have left on bottom? Can I leave the top of the fraction empty? You have to put a 1. Because remember, x plus 2 divided by x plus 2 is technically 1. X minus 2 divided by x minus 2 is technically 1. Anything divided by itself is 1. A little. Okay, so this one, remember, we want one happy fraction over another happy fraction. Is that a fraction? On the bottom? No. So I'm just going to put over 1. Now is it a fraction? Yes. So I'm going to rewrite it as division. Okay, and we know that when we divide, we flip what's after the division symbol. Now, does x squared minus 9 factor? Yeah. It's a perfect square minus a perfect square. So I end up getting x minus 3, x plus 3. 3x does not. Changing it to multiply, and nothing over here factors either. Yes. Yes, because it's always going to be division if it's a fraction. So we have these x plus 3's that cancel. Does anything else cancel? No. Well, 1 times anything is just itself. So this gives me x minus 3 over 3x. There's my answer. Because this is a perfect square, because x squared gives you x squared, and this is a perfect square because 3 squared gives me 9. So I broke it down to difference of squares. Just like we did here. To here. Okay. So let's look at example 3. Now this is kind of what we were talking about when we said we need them set up as a whole fraction. This is not a whole fraction. This is x minus a fraction. So we need to put this together, which is like what we were doing the last couple days with adding and subtracting. So what do they have to have before I can put them together? A common denominator. So this has a 7. This technically has a 1. Can 1 turn into 7? By multiplying by what? So then I get 7x minus x over 7. Now here, can 1 turn into 14? Yes, by multiplying by 14. And we get 14x plus x over 14. Now, I want you to realize here, y'all, 7x minus x is like terms, right? So what's 7x minus x? 6x over 7 over, what's 14x plus x? So now that I have them simplified, which technically you could have waited, but I didn't. Okay, we're going to set it up as division. So I get 6x over 7 divided by 15x over 14. This is division, so I'm going to flip. And I get 6x over 7 times 14 over 15x. Now, I do want you to realize that if you understand that you're flipping the denominator, do you really have to write this step every time? No. So if you see that, that's fine. I'm going to show it every time today because I want you to understand why. But if you're understanding that, then you can just go ahead and do it from here to here kind of thing. Does that make sense? Okay. So knowing that, what simplifies here? Does 6 over 7 simplify? What about 6 over 15? What goes into both of those numbers? 3. So this would technically be 3 times 2, and this can be 3 times 5. Okay, and I want you to realize this can be 7 times 2, which means 3 and 3 cancels, 7 and 7 cancels, and I'm left, and technically the x and x cancel, so I'm left with 2 times 2 on top and 5 on bottom. Any questions on that one? Okay, so the next one is already one happy fraction over one happy fraction. I don't know if they're really happy, but you know, it's there. So we're going to go ahead and set it up as division. So I can break down almost every piece of this except for the 5x. First off, these 3 pieces have GCFs. Okay, so what's my GCF here? Does 8 go into 72? Yes, how many times? Huh? 9. Does 5 go into 10? So 5 is my GCF, and what am I left with? If I take out x plus 2. Now I'm going to change this to multiplication and flip. Does 4 go into 12? And I get x minus 3. Now, is this fully factored? No, what piece is not? The x squared minus 9. X squared is a perfect square, and so is 9, because 3 squared. So this can break down to 8 x minus 3 x plus 3 over 5 x plus 2 times 5x over 4 x minus 3. Now that it's fully factored, I can cancel and then simplify. So what cancels? What else? 5. Now, can 8 simplify with the 4? Yeah, what's 8 divided by 4? Okay, nothing else simplifies, so I'm left with 2x plus 3 over x plus 2. And now nothing here simplifies, and that's my answer. So there's 2 more on the back. These are a little more gross, but they're not bad. Okay, so this first one, I want you to realize that, remember, anytime something's not all the way across fraction, we need to make it. So these are over 1, but this has an x. Can I multiply both of these by x, top and bottom? Yeah. Now, what does x times x give you? Squared. So I'm just going to put a squared there. And now I have 3x squared minus 5x minus 2, and now all of them have a denominator of x. Same concept here. It already had one. So I didn't have to give it another one. Okay, so that has an x, these have 1, so I can make these x's by giving everything an x again. So this is division. And now, before I flip this, I'm going to factor the tops of those. How would I factor the tops of those? Well, how many terms are there? 3, so I'm going to do the snowflake. So I get A is 3, B is negative 5, C is negative 2. 3 times negative 2 is negative 6. A is 3, and B is negative 5. What multiplies to give me negative 6 but adds to give me negative 5? Not quite. Because 2 negatives don't multiply to give you a negative. If the top was positive, that would be correct. So remember, we're technically subtracting here. Somebody said something? What'd you say? Not quite. Yes. So it's going to be negative 6 and positive 1. Because 1 times negative 6 equals negative 6, and 1 plus negative 6 equals negative 5. Now, 3x over 1 does not simplify. So that's one of my factors. But remember, 3 over 6 does, because 3 goes into both of those, and I get x over negative 2. So that's my other factor. I'm going to go ahead and change this to multiply. I'm going to put the x on top, and I'm going to factor that one now. So A is 3, B is 10, C is 3. 3 times 3 is 9, B is 10, A is 3. So what multiplies to give you 9 but adds to give you 10? What? 9 and 1. So 3x plus 1 does not simplify. But 3x over 9 does, because 3 goes into both of those. And I get x over positive 3. Now that everything is factored, we can cancel and then resimplify. Okay, so what cancels? What else? And what am I left with? Now, I don't know if you noticed that I cross everything out, but I squiggle the x's, and it's because I personally, when I cross out an x, if I'm not changing colors, it still looks like an x, and so I think they're still there and they're not. So if you're like me, squiggle the x's. Okay, one more, and this one looks super terrible, but it's really not as bad as it looks. Okay, so I want you to realize that we have a denominator of a plus 1 and a. And we need to have a common denominator so we can combine those into one fraction. But you can't just add 1 here and here and then call it a day. You have to multiply to make a common denominator, so I can't just put a plus 1. So since this has an a, this one needs just an a. And since this has an a plus 1 and this one doesn't, this one needs an a plus 1. So now my common denominator is a times a plus 1. And I get a. Now, I'm going to bring this minus sign up here so I don't forget about it, because a lot of times we forget about them because they just blend in with the two division or the fraction bars. So I get negative 1 times a and negative 1 times 1. Well, technically I want you to realize this is 1a. And then 1 over a. How does this simplify on top? What does it become? Huh? Just negative 1. 1a minus 1a is 0. So I get negative 1 over a plus 1, divided by 1 over a. I'm going to change that to multiply. So what cancels? The a's. Technically, you can say the 1s, and you're left with just a negative on top, so you're going to have to put that negative 1 right back. Okay, because negative 1 divided, or 1 divided by 1 is 1 anyway. And then we're left with the a plus 1 on the bottom. So that one looked pretty terrible, but it really wasn't as bad as it looked.